Good morning, Year 8. We're going to go through how to do pages 15 and 16 of the number 7 pack today, because that's going to be your work for this lesson. Now I've edited these questions slightly. You'll notice that your first 3 questions on page 15 do not match these ones, okay, and these ones don't actually appear in your questions because I didn't want to just do 3 of your questions for you. Okay, a bit evil of me, I know. So these are similar questions, and I've chosen 3 with kind of mixed difficulties. The first one's one of the easier ones. The second one is a slightly harder one, and the last one here is one of the harder ones that you'll see in the pack. You've got a similar set of questions to each of these, and you'll see why in a second. But let's first fill in these terms up here, okay, the meaning of these terms. Now I'm going to just steal the definitions of these from the glossary in your pack, because why not? I mean, it's perfectly worded, but you might have some intuition as to what these words mean anyway. Okay, so terminating, if something terminates, that just means it stops. Okay, so in terms of decimals, this means a decimal which has a finite, as opposed to infinite, by the way, so a finite, a set number of digits. That is, it comes to an end and doesn't go on forever. Okay, so a terminating decimal might look like 0.6, for example, okay, or 0.625, okay, but it doesn't just keep going on and on and on. Some of you may know that those that do keep going on and on are called recurring decimals. So a decimal which has a repeating pattern or repeating digits is called a recurring decimal. Okay, in fact, some countries don't even use this word recurring, they just use repeating, so repeating decimal, some would call it. It's called recurring in our country. And then finally, these 2 are ones that you probably knew. These are a bit easier. The numerator is the top number in a fraction, showing the number of parts of the whole, and the denominator is the bottom number in a fraction, showing the number of parts the whole is divided into. Okay, so I'm going to very quickly show you how to do each style of question. I mean, it's the same method for all of them, and then you can have a go at these pages in your pack. Okay, just grab a pen. Right, so first things first, to turn a fraction into a decimal, we're going to use bus stop division. There are a couple of methods. One of them is kind of a quicker way, but it depends on the fraction being over 10 or over 100 or 1,000. Okay, and sometimes it's not easy to scale a fraction so that it is over those things. Okay, that's what you've been doing the last few lessons. But we're going to just look at another quick way to do it, and that's just by doing the division that the fraction is representing. Okay, the fraction is a division. This is saying 3 divided by 4. If you've ever wondered where the divide sign comes from, then this line here is the same as this line here. It is saying this thing divided by this thing. Okay, so we're going to do 3 divided by 4, and of course if we're doing it that way around, 3 needs to go inside the bus stop, so the numerator is the one that goes inside the bus stop. 4 is going to go outside the bus stop, the denominator is going to go outside in all of these questions. Now I've left a bit of space to the right hand side because I know I'm going to need to use it. I know this is not going to give me a nice whole number here. So let's see what happens. How many 4s go into 3? Well, 4 is bigger than 3, so the answer is none. And at this point, we could write a remainder, but that's a bit primary school. We're going to carry on the bus stop division, but we're going to put a few decimal places after the 3 and see what happens. Now, I don't want to change the number, so those decimal places have to just be zeros, 3.0. I've not changed that number by putting a 0.0 in there. But what it has allowed me to do now is put a remainder up here next to the 0. I didn't use any of these 3s, so they're going here. Okay. If I put a decimal point in the bus stop, though, I need to put one in the answer as well. So how many 4s go into 30? Hopefully you know that that is 7. 7 4s are 28. Okay, so that leaves me a remainder of 2. And I don't have anything to put that next to, so again I'm going to put another 0. Okay, because 3.00 is exactly the same as 3. How many 4s go into 20? 5. Okay, so we stop there. There are no more remainders, so nothing to add next to another 0. And this decimal has stopped. So the answer, the decimal equivalent to 3/4 is 0.75. And because it stops, that means it is a terminating decimal. Okay, let's move on to a slightly harder one. On this one, we're dividing 2 by 3. So 2 is going inside the bus stop, 3 on the outside. Okay, and I know I'm going to need some zeros. Okay, you can add a few, or you can just add them as you go. I like to add them as I go. Right, how many 3's go into 2? None. So the 2 is going to go here. How many 3's go into 20? Okay, well the nearest multiple of 3 to 20 is 18. Well, sorry, the one that's under 20 is 18. And that's 6 lots of 3. So 6 3's go into 20, leaving 2 remaining. Aha, now we've got 20 again. 6 3's go into 20, leaving 2 remaining. You can see where this is going to go. Okay, we're just going to keep getting 6, 6, 6, 6, 6 on the top, and we're going to keep getting 20s on the bottom. So there's no point writing this forever. In fact, we can't. We'd be here for the rest of our lives. So we need a better way to write this. And some of you may know that when we have a recurring digit, we put a dot above that digit to indicate that that digit is going to carry on repeating. So this is a recurring decimal, and we would just say 0.6 recurring if we wanted to talk about that decimal. The final one, a bit trickier. You're going to have a bit of patience with these ones. Need a bit more room, I'm afraid, as well. So we're going to do 2 divided by 7. Yes, I did just make that bus stop that long. Okay, you'll see why. So immediately I'm going to add a 0.0. How many 7's go into 2? None. How many 7's go into 20? 2 7's are 14. So that's 2. And that leaves 6 remaining. 6 remaining from 14 to get to 20. How many 7's go into 60? Well, 7 8's are 56. And that's 8. Leaving 4 remaining. Okay, how many 7's go into 40? That will be 5. 5 7's are 35, which leaves 5 remaining. How many 7's go into 50? 7 7's are 49. Leaving 1 remaining. How many 7's go into 10? That's just 1, which leaves 3 remaining. How many 7's go into 30? That's 4, leaving 2 remaining. And you can see at this point, we are back to having 20, which we had over here. So we're just going to get another 2 above this, which is going to leave us a remainder of 6. Okay, so we're going to get this pattern again. So in this question, the answer would be 0.285714, 285714, 285714, and so on and so on. So how do we represent a whole pattern of repeating digits? Okay, tempting to put a dot above all of them, isn't it? But there's a quicker way. If we just put a dot above the start of a repeating pattern and the end of a repeating pattern, that indicates that that whole pattern there then repeats after each time. Okay, so in some countries again, or a different way of showing that is some representations use a line above all the things which repeat. Okay, so there's different ways of showing it even in the maths world. But we've just proven that this is another recurring decimal, just a slightly harder one. Okay guys, best of luck on those questions. If you have any questions, send me a message on Google. I can't promise I'll get back to it straight away, but this should be enough to give you a good go on those pages. Thanks guys.